future. They won't use roads. Instead, they'll take to the air. Fully computerized, they'll drive along electronic highways in the sky. But if the sky is the future, right now, we're still on the ground. There are 475 million of them driving around the world today. That's one for every 12 people. They've changed a lot in the last 100 years. These remarkable machines have had an enormous impact on the way we live. Originally designed simply to be faster and more reliable than horse-drawn carriages, these machines are now designed to fulfill our every desire. Some are beautiful. Some are monsters. Others are just plain fun. They can also travel extremely fast, some at over 300 miles per hour. They can go off-road, even drive on water, and perform tricks. There are thousands of different models on the road today. Each one is built to catch the eye of a prospective buyer. It's the most competitive industry in the world. To keep ahead, manufacturers are always trying to create a new or more exciting car. This is the Lotus Elise. It's light, it's stylish, it's fast. Its revolutionary design combines an eye-catching shape with breathtaking performance.
Yeah, the Elise is quite an interesting vehicle. One of its main characteristics are the fact it gets its performance through its low weight. So it doesn't employ a very expensive or highly powerful powertrain or engine unit. It just works on the basis of the lightweight, gives you all the performance you need as a road car.
Despite a small 1800cc engine, it's very fast. It can accelerate to 125 miles per hour.
But the top speed is not the thing we're really aiming at, it's the acceleration. And the 0 to 60 mile an hour time for that is about 5.5 seconds. With the motorsport version, which has 190 horsepower, we're achieving just over 4 seconds to 60 miles an hour and just over 10 seconds to 100 miles an hour, which is a pretty competitive vehicle.
The unique feature of the Elise is its construction. It's made from aluminum. That's not new. Other cars have used this lightweight metal. But what is new is the way it's put together. Instead of welding the parts, which would weaken the aluminum, the chassis is bonded or glued. The end result is a chassis so strong that it can be driven without the body. The Elise's innovations don't stop there. The front of the car is a crumple zone, which folds up like an accordion to absorb the impact of a head-on crash. The Elise is also environmentally friendly. The aluminum is easily recycled.
Fuel consumption is directly related to CO2 emissions, greenhouse gases. By having a fuel-efficient car such as the Elise, which does an average of about 40 miles to the gallon, with such fuel efficiency that the car is really quite friendly in terms of being green.
All this has made the Elise a winner. There's a 2-year waiting list to buy one. For some designers, a car like the Elise isn't enough. They want to build something much more radical. Custom designers take a production car, reshape and rebuild it to create a one-of-a-kind, the custom hot rod. The king of the customizers is Coddington.
I grew up in a small town in Idaho, and my brother was about 5.5 years older than I was, and that was in the 50s, And him and his buddies always had the hot rods and stuff, and so I took an interest at a pretty young age. And so I built my first car. It wasn't the nicest thing in the world, but it was a start. And then after that, I ventured out to Southern California, where I thought that I could find the hot rods and have that kind of a life. I didn't know it'd be this great.
Coddington has turned his boyhood dream into a multi-million-dollar industry. His cars are classics.
We build our cars low. It makes them handle a lot better. They look good. They're very, very safe, and of course all our wheels are tested. And this car I'm sitting in right now was actually driven from here to Indianapolis this year across country. So they're very roadable, and they're a lot of fun to ride in. My true definition of a hot rod would be like a 32 Ford Roadster with no fenders, that had a real nice setting stance to it, big tires on the back, little tires on the front, a nice sound to it, and a real bright red.
West Coast hot rod culture has now started to influence Detroit car companies. In the Motor City, classic cars are coming back.
Prowler started from a program that we ran at Chrysler Pacifica, which we called Idea Fair. One of the designers had a little sketch of this retro car. In fact, I think he called it retro car. And it went from there to a small scale model, to a full-size clay model, to the show car, to production. All along the way, it captured everybody's imagination that saw it.
Built by the Chrysler Corporation, this is the Plymouth Prowler. Chrysler has taken the best of the hot rod and put it into a reliable production model. But style isn't everything. For some, what's under the hood is all that matters. If it's awesome power you're after, then look no further. This is the Dodge Viper. It has a 10-cylinder engine, produces 450 horsepower. With a top speed of 190 miles per hour, it's one of the fastest production cars in the world.
450 horsepower is kind of hard to ignore, and it brings out some probably not very safe driving tendencies, but I mean, you just feel this power that you have control over, and it's coming right through the shift lever and the wheel, and you see the hood rising up in front of you, and it's just got so much torque. It just feels like you were reborn into Arnold Schwarzenegger's body or something.
The Viper has greater power than any other American road car.
It is a single-minded, single-purpose car of being a very powerful, very fast, very good handling sports car.
Every industry has its mavericks. The car industry is no exception. This car was created by one of the world's leading car designers, Jim Reuter. It takes its inspiration from a surprising source, the Lockheed Martin F-117A stealth bomber. It disregards standard design concepts and follows the angular shape of the plane. It's made up of a series of carefully angled panels. The jet theme continues inside the car. The driver sits in the center of the cockpit. Even the instruments are based on the F-117. Reuter's stealth car may look eccentric, but he also helped design the Lotus Elan and the world's most expensive car, the F1 McLaren.
The stealth, if you like, is the ultimate edge design. It's totally made up of corners and flat facets. It's not an organic, evolved shape. It's very much a statement against all the round, blobby shapes.
performs flawlessly. It can accelerate from 0 to 60 in 6 seconds and has a top speed of 150 miles per hour. Sadly, Jim never gets to push his car all the way. It hasn't been coated with the F-117A's special radar-deflecting paint, so there's no chance of beating speed traps. One of the greatest design challenges has been to build a car that could travel anywhere, literally. The Aqua car has long been a favorite of comic books and movies. Once under the water, the wheels would retract inside the body. It would be powered by propellers, which would push the streamlined vehicle to 20 knots. The small fins would steer it through the water. Tanks would provide air for the driver. The body would have to be specially reinforced to cope with the immense pressure of deep water. The windshield would be made from specially reinforced glass. This car is a fantasy, but there have been many attempts to build a real car that could rule the waves. The Amphicar was designed by Hans Trippel and produced in Germany in the early 1960s, but it was a failure. It had a basic design fault. Its steel hull rusted in salt water. 40 years later, one car manufacturer finally succeeded. The Dutton Mariner is the brainchild of designer Tim Dutton.
Well, I've been making cars for 25 years now, and I thought I wanted to try something that was slightly different from what I've been doing before, which is just normal road cars. Living on the coast, I do a lot of water skiing and playing around with boats at the weekend, so I thought, let's try and combine the two.
The world's only production amphibious car. It's based on a standard Ford Fiesta, but with a boat-shaped watertight body shell constructed from fiberglass. The hull is sealed around the wheel struts.
Really, it's just like a big bath with an engine in it. That's why the engine keeps dry, is because there aren't any holes between the hull and the engine bay.
Look like a bathtub on wheels, but it drives like a normal car with a top speed of 95 miles per hour. On land, the engine powers the wheels. In water, it powers jet propulsion units. As it enters the water, covers over the two jet units are raised, and power is transferred from the wheels. The movable jets steer the car.
Well, the very first time we took a prototype in the water, obviously it was quite frightening because we hadn't done it before and we didn't know whether it would just keep going down the slipway and just keep going down, down, down under the water. When we do take people out on demos, you can see they're sort of almost holding onto the dashboard because although they know it's going to float, it's still the thought in the back of the mind that I'm sitting in a car and I shouldn't be doing this.
There's a sealed bulkhead between the engine and passenger compartment. If the car's hull is pierced below the waterline, the boat won't flood and sink. The car has a top speed of 7 knots and can cope with rough seas. In fact, Tim has driven across the English Channel to France, an ocean journey of 30 miles.
It's just the expression on people's faces when they see something plummeting into the water and it actually floats off into the distance. And it's good fun anyway. We've sold cars to people that actually use them for work and for getting from island to island or from a big boat to the shore.
Throughout the history of the car, there have always been designers who want to leave their mark. At 22 feet long, the Type 41 Bugatti Royale was the largest production car ever. Only 6 of them were ever built. Designed to be the ultimate luxury carriage for royalty, it ended up a museum piece. The longest cars on the road today are a California invention, the stretch limo. These luxurious vehicles can be as long as 80 feet, but they start life as a mere 15. Some of them are converted here in a factory in Southern California. This is no high-tech operation, no robotic production line. The original car is just cut in half. They're going to stretch this one by over 20 feet. The new chassis is custom-made out of steel bars and panels. They have to be welded together in an arch to prevent the car from sagging in the middle. Society where bigger is always better, stretch limos are the ultimate symbol of success.
Wienermobiles on the roll.
One of the weirdest cars ever built was the Wienermobile. First made in 1936 as a promotion for the Oscar Mayer Food Company, it made its chef and co-pilot, Little Oscar, a household name.
Look! Little Oscar!
Here's little Oscar and his Wienermobile. Little Oscar, the world's smallest chef.
The Rolling Frankfurter was the first internal combustion hot dog. It brought a smile to onlookers wherever it traveled. Now the company has built a Wienermobile for the 21st century. It was created by world-renowned car designer Harry Bradley. Despite its shape, it sailed through in wind tunnel tests. It may be 27 feet long and 10.5 feet high, but it can reach a speed of 90 miles per hour. It's the ultimate wiener. There are millions of cars on the road, virtually every one of them built on a production line. Henry Ford put the world on wheels by revolutionizing car production. In 1913, he introduced the first moving assembly line, increasing efficiency and dramatically cutting the cost of car manufacturing. Cars were available to the masses, and for the first time, anyone could go anywhere. Nearly a century later, 37 million passenger cars roll off production lines each year. 100,000 new cars every single day. One of the latest cars off the assembly line is the Jaguar XK8. It's sleek, it's powerful. It continues the tradition of classic Jaguar cars. The XK8 is the product of 2.5 years of design and testing at a cost of over $500 million. Most cars start out as just a sketch or an idea. After a rigorous design analysis, the best are then turned into clay models to check their three-dimensional appeal. Clay is used because it's fast, cheap, and malleable. important that the car looks good, but it must also be practical. It must be aerodynamic to reduce drag. If the drag is too great, the car will drink too much fuel, and it could be unstable at high speed. It's also important that the car sounds right, both inside and out. The cars must be able to run reliably in all extremes of weather. They're tested from 131 degrees Fahrenheit to 40 degrees below. Safety is critical. Every year, over 43,000 people die in car accidents in the U.S. alone. Crash tests help analyze the destructive forces in collision. Early rigid-bodied cars, the passengers were often thrown around like rag dolls. Modern cars still have a rigid structure, but only around the passenger compartment. The rest of the car body is designed to collapse and absorb energy. Airbags provide even more protection. Crash tests could soon be a thing of the past. Computer simulations can now predict the destructive energy of impacts without ever destroying a real car. Every single component of a prototype is tested to destruction. For safety, the suspension is tested to the limit. It can take as long as 6 years from the original concept to the first production model. Each new car is constructed from up to 30,000 individual parts. Body shells are pressed and welded from sheet metal and are sprayed with as many as 15 coats of paint. Surprisingly, in the US, the most popular color is light brown. Engines are constructed with automated milling tools. All surfaces must be accurate to thousandths of an inch. If they're not, the components will wear out or seize up. The internal combustion engine was invented over 170 years ago. The original model had only 4 horsepower. Modern engines are far more powerful, but they still have the same basic mechanism. Gasoline and air are sucked into a cylinder and compressed by a piston. The air-fuel mixture is ignited by a spark plug and burns at 3,000 degrees. The gases from this mini explosion expand and drive the piston down, generating power. An average medium-sized car takes 22 hours to build. Last year, 6 million cars rolled off production lines in the U.S. alone. The VW Beetle is the best-selling vehicle of all time. Since production began in 1938, over 21 million have been sold. It's a classic design, which still dominates one of the toughest motorsports in the world, off-road racing.
My name is Judy Smith, and I'm, I don't know, basically a housewife, but when I can, I drive a Class 11 race car in the desert, in Baja, as far away from pavement civilization as I can get.
There are different classes for off-road Beetles. Judy Smith's is a Class 11. This is a Class 5 1600, a Beetle with limited modifications. And this is the most extreme Beetle of all, the Class 5 Unlimited, the ultimate desert racer. The Beetle was originally designed by Ferdinand Porsche when Hitler asked him to design a Volkswagen, German for people's car. Porsche designed it to last.
People use VWs as off-road cars because of the fact that they were air-cooled rather than water-cooled. Didn't have a radiator, you didn't have to worry about running out of water or boiling over. And because the motor's in the back, over the drive wheels, and they get such good traction in loose, soft terrain.
Judy has made only a few alterations to her Beetle. She has fitted slightly bigger tires, slightly stiffer shock absorbers, and a roll cage. But it takes more than just a good car to survive in off-road racing.
You need to learn how to read the desert, but then you need to be able to make decisions and stick by them. You can't be indecisive. You can end up over a cliff or stuck in a river or stuck in the ocean. So the decisions have some importance. You can get yourself into a real bind. It's the last adventure left to me. I'm born too late to take the covered wagons across, and I'm born too early to take a spaceship and go out to Saturn or something. But I can drive in Baja, and I feel like an explorer. I feel like I'm seeing new things. I am seeing new things. I'm doing something that the average person doesn't do, can't do, won't do. I love it.
The next step up is the Class 5 1600. Wayne Cook has modified his Beetle to produce a world champion.
The street legal Beetle is quite a marvel in itself. All we've done is make it better. Make it just a little bit bigger suspension, a little bit bigger torsion bars, a little bit bigger of everything. It will do just about anything except for climb a block wall.
The most extreme off-road racer is the Class 5 Unlimited, a Beetle on steroids.
My name is George Sulu Jr. and I drive Class 5.
Capable of speeds of 110 miles per hour over the roughest terrain, this car has no limits.
The ideal situation for this car is to have long suspension, which allows you to go faster through rougher terrain. It's kind of a crowd-pleasing car because it'll fly well and it maintains a good attitude in the air, which lets you gain on your opponent and actually finish the races in faster time.
It has a custom-built chrome moly frame with a 3,000cc engine suspended over the back wheels. It has 4 massive shock absorbers at the back with over 2 feet of travel. These absorb the impact of landing and keep it stable over bumps.
The greatest joy, like you go over a jump and you fly into the air, you're leaving Earth for a while. It gives you a tremendous feeling of accomplishment when you've battled the elements and come through.
The basic Beetle design hasn't changed from 1938 until It's styled on the old Beetle, but that's where the similarity ends. It has abandoned original design features like the rear air-cooled engine in favor of a water-cooled engine, and now it's under the hood. It's the Bug for the 21st century. Some cars are built for just one purpose: speed. The spiritual home for speed freaks is the Bonneville Salt Flats, Utah. Drivers from all over the world come here for the ultimate adrenaline rush. One driver who returns each year is Al Teague. He drives the fastest piston-driven car in the world. Its V8 engine has been supercharged to generate 1,600 horsepower. This is no passenger car.
When you go past the mile markers, when you start to sight on another one a mile away, and in 8 seconds you're to it, you know you're moving. It's 2 football fields every second.
His bullet-shaped car shoots along at a staggering 432 miles per hour.
And you can't describe it. The adrenaline's going and everything just tends to slow down.
Al Teague's car takes 5 miles to reach top speed. Drag racers do it in just 400 yards. They are the absolute expression of man's need for speed. They are built for only one purpose: to accelerate to top speed in the shortest possible time.
Hi, I'm Kenny Bernstein, driver of the Budweiser King Pro Long Top Fuel Dragster.
The ultimate drag cars are top fuel dragsters. They go from 0 to 100 miles per hour in 1 second. They are the most violent, most powerful, most dangerous cars.
I love the top fuel car because it's the quickest and fastest. It's the king of the sport.
Kenny Bernstein lives for speed. He is a 6-time drag racing champion. He drives the fastest drag car in the world. It accelerates to 318 miles per hour in 4 seconds. It's a masterpiece of engineering created for one purpose.
The reason the top fuel dragster is long and narrow and the motor's behind is for ultimate traction. The longer the car, the longer the wheelbase, the further back we can put the engine on the rear end, the quicker and faster we go because it transfers the weight to the rear tires. And the absolute beauty of this car is when it leaves the starting line and it carries the front end, all 100% of the weight is on the rear tires. That allows you to go the quickest and the fastest.
Its awesome engine generates an astonishing 6,000 horsepower, 7 times more than an Indy car. It can do this because it runs on nitromethane.
Nitromethane is what we have used for years and years because it makes the most power. Nitro won't burn if you put it on the ground and light a match to it. It works with being compressed. And when you put it inside a combustion engine and you compress the piston to the cylinder head, it becomes a major bomb, so to speak, and that's what makes horsepower.
Nitromethane burns 6 times faster than gasoline. Every 4 seconds, the engine burns over 11 gallons of fuel. The challenge is to get the mixture of fuel and air just right to deliver the maximum power. It's a delicate balance. If the mixture is wrong, the explosive force can smash the pistons out through the engine block. Kenny is competing in the NHRA Championship, along with Corey McLenathan, who drives the McDonald's car.
Hit 60 foot
in less than a second at over 120 miles an hour. By the time you get through the quarter mile, it's running 318 miles an hour. You know, if that doesn't say kind of what the reason I do it, I mean, I don't think anything else will. I love speed. I love the fast acceleration. Not too many people get to pilot one of these cars.
Before each race, the tires are heated up into burnout. This brings them to the optimum temperature of 140 degrees and lays down a fresh layer of rubber for extra grip. The tires are wide and flexible, but when the cars accelerate, the tires expand vertically and instantly explode.
When a car leaves the starting line, the G-forces can register as high as 5 Gs when you're going over 260 miles an hour in about 2 seconds. Inside the race car, you're in slow motion. You don't realize how fast you're going. It's like being in a tunnel, and you really don't see side to side, obviously. You're going way too fast. There's not a lot of time to listen to the radio or turn the air conditioner on.
This is not a sport for the faint-hearted. Kenny is pinned back by a force of 5 Gs, almost twice that of a space shuttle launch. The cars can explode into flames at any time.
Of course it's dangerous. I mean, you go a projectile and go 300 miles an hour and something happens where you crash, I'd say it's pretty dangerous, you bet.
After each run, the car is completely overhauled. The team checks 40 separate readings from the onboard computer. By comparing readouts with race times, the team can tune the engine to the optimum settings. Despite all his team's preparations, Kenny had problems and was eliminated in his next round.
No, we're not happy. You know, losing the first round is about the biggest downer you can possibly have in this sport. It's just one of those things that happens from time to time when you're trying to push that envelope and get the best performance you can.
Corey McLenathan was having more success. Not only did he win the event, but he also beat Kenny's record. He reached an incredible speed of 321 miles per hour and became the fastest drag racer in history.
This McDonald's car run is so good. Dad, Mom, everybody at home, man, this has been great. I'll tell you, the Revell Nationals first one, the good one to win.
Designers may push the boundaries of car design. Stunt drivers push the boundaries of performance. Stunt drivers have been wrecking cars ever since they were invented. The Joey Chitwood Thunder Show has been satisfying our appetite for auto mayhem for over 50 years. They don't use special stunt cars. They use standard Chevrolets.
First thing you got to do is you got to go up the ramp properly, which might sound easy, but you have to go up the ramp exactly the same way in order to know exactly what the car's going to do. Then after that, you kind of got to go by feel. Whatever your balance in your head tells you to do, you got to react with the wheel, actually a little bit ahead of time.
You must hit the ramp dead on. A few inches either way and the car would flip over. To stay balanced, he rocks the steering wheel back and forth.
It's the most difficult thing you can do with a car, at least that I've ever done, and I think I've done just about everything. It just takes years of practice to get the feel of the car to maintain the balance.
But the real crowd pleasers are the crashes. To prevent injury, the windshield is removed because the car will be smashed to pieces with the stuntman inside.
We do a dive bomber crash where we go up a ramp and actually dive bomb right into the windshield of another car. Speed is real critical. It's more or less like a ramp to ramp. You just land on a car and you got to hit the car in the right place. If you fall short, you hit the engine area, which would be a lot more impact. So he tries to stick it right inside the windshield of the other car.
The main thing is your speed and alignment on the ramp. If you miss the ramp on a dive bomber, you're going to get hurt. That's the bottom line, you're going to get hurt. Good jolt to the body, but we've learned how to prepare for that first initial impact. You're sore after a day's work, but if you don't break nothing, it's on the next day.
The wildest crash is the Dominick. Looks completely insane.
At the high side, here he is, the master of mayhem, Wild Bill.
But it's not the most dangerous stunt. That's the cannon jump. The tube is only 7 feet 1 inch wide. Tim's car is 6 foot 11 inches. There is no room for error.
We only have 1 inch of clearance on either side going in the cannon, so if you were to miss a line, that would probably be disastrous because you'd probably come out either on your side or upside down. And of course, you got to hit the landing ramp just right. If you were to be short, you would get lumber through the windshield and be seriously injured. If you do a good jump, it's like running over a railroad track real fast, but if you do a bad one, there's a lot of impact on your back. The car can sustain quite a bit of damage too if you don't make a good jump.
Ever since Henry Ford built the Model T, car manufacturers have been attempting to design the perfect car. Now the race is on to create a car for the 21st century. The key to success will be its fuel supply. As fuel resources and environmental legislation tighten, engineers are battling to come up with an alternative to the internal combustion engine. At the top of the list is electricity. The first production electric car is the EV1, made by General Motors. It's powered by rechargeable batteries. It's quiet, emits no exhaust fumes, and is recognized as the world's most energy-efficient vehicle. It feels just like a gasoline-powered car and has a top speed of 18 miles per hour. Contrary to popular belief, electric cars can travel very fast. This car, the Lightning Rod, broke the electric land speed record in October 1997 at 215 miles per hour. But there's one big problem. Even modern batteries can only store a limited amount of power, so the cars have a limited range. One solution is to generate electricity from a renewable source. Solar cars get their power from the sun. The best solar cars come to Australia to take part in the grueling 3,000-kilometer race, the World Solar Challenge. The last race was won by the Honda Dream. It is covered with 4,500 solar cells, which together generate the same power as 2 hairdryers, and it costs $1 million. It completed the course with an average speed of 55 miles per hour, with top speeds of 68 miles per hour. Another development being explored is the automated highway system. Here, people won't have to drive their cars. Instead, onboard computers will take control. The car carries sensors and cameras which detect other vehicles and the roadside. An onboard computer processes this information, plots where the car is, and maintains a safe distance from the car in front. It can even pass on its own. The driver can relax while the car does the work. In the future, drivers will enter designated lanes and switch on an autopilot. The system will eventually be linked to global positioning satellites so the car can travel anywhere. But the car of the future still faces an immense problem: the huge numbers of other cars on the road. Traffic delays cost America millions of dollars in lost productivity each year, and it's a problem that's getting worse. Soon highways will be one big, permanent gridlock. The car of the future will go where there's no congestion. They will take to the one avenue that isn't clogged with traffic. They will take to the sky. It's an idea that has long inspired and obsessed Dr. Muller, an automotive designer from California.
We have this, I call, most greatly unused natural resource in the world today, the airspace above us. It's there, it's basically rarely occupied, and everybody's sitting on the ground in traffic jams.
It's not a new idea. Many designers have wanted their cars to fly. In the 1930s, there was the Aerobeel. It had detachable wings. It flew, but didn't handle well on the ground. The Airphibian had detachable wings and propellers. But none of these cars could hover, so on the ground they still had to join in with all the other traffic. Dr. Muller's solution is a car that never drives along the ground. His inspiration came from the unique ability of the Hummingbird.
The Hummingbird could do everything that I would love to do if I was in a traffic jam. Get off, go very fast, come back, land. And this vehicle is a mechanical form, rather larger, of course, than a Hummingbird, but mechanical form of the Hummingbird, you might say.
His first flying machine was the M200. More flying saucer than car, it proved that his lightweight engines would generate enough controlled lift to fly the vehicle. The safety tether was a requirement of his insurance policy. With the technology proven, Dr. Muller moved on to design the flying car. He conducted extensive wind tunnel tests until he came up with this, the M400 Mark I. This full-size prototype didn't fly, but did help Dr. Muller decide on his final design. The M400 Mark II. Currently nearing completion, this Sky Car will fly. It has 8 turbofan engines, each driving a multi-blade fan. Behind each are adjustable vanes, which direct the thrust downwards for takeoff and horizontally for flight.
The most important feature of any of the vehicles we developed is the fact that they can take off vertically. In a very small, confined space. They don't have a large rotating rotor like a helicopter. So yes, you can take off vertically from your backyard, in theory, and then transition into aerodynamic or forward flight.
The car will be flown by onboard computers, which will be linked to an invisible electronic highway system.
You won't be a pilot, and you really shouldn't call yourself a pilot. You'll be a passenger. You'll get on board, you'll select a destination, and it'll just take you there and land you there. And I don't think you'll ever see this vehicle in large numbers in any other capacity but that one.
The Sky Car will take off vertically and enter its designated electronic route. System will be voice activated. A new destination can be selected at any time. The computer will then choose the best route. Fully automated, the cars will cruise along electronic corridors mapped out between the buildings. To avoid mid-air collisions, the system will plot the movement of each vehicle to within inches. Everyone will become airborne. This may seem incredible, but it will happen.